We're learning to recognize a straight line from its equation, and its equation is generally y equals mx plus c. Now the m that's in there, that stands for the gradient, okay, and we covered that in the first video that we did when we were looking at how to understand gradient and what that actually means to us. A kind of newer one for today is that we're going to be looking at this letter here, which is C. And what that is basically is the y-intercept, and where the line, the straight line, crosses over the y-axis that's here, okay, the one that's vertical. Okay, so what we have here as well, so y is a y-coordinate, x is an x-coordinate, m is your gradient, which will determine the slope of the line, and the c is the y-intercept. Okay, so we're going to be doing this on an app called Desmos. So what I'd like you to do is to go to either the App Store or wherever you need to find it and download Desmos, freeze the video, download Desmos, and what we'll do is we'll get on with some of this work today. Right, I've already got it installed. So what I'll do is I'll go to Desmos just now. And the first thing that I've got here is I've got a keypad down the bottom. I've got an area where I can plot some graphs, some straight lines. And these are the lines that are going to appear up in the top left-hand side. Okay, so if you remember from the last time we did this a video on gradient, we knew that the gradient of a line is 1 along, 2 up for this one here, 1 along, 2 up, so that there would be a gradient of a 1 on the bottom, a 2 on the top of a fraction, which would give us a gradient of 2. So that's the gradient of 2 that we can see over on the left-hand side, where this wee hand's pointing to, okay? The c value is the value that we've got here, which is 1, and that 1 is where we cut through the y-axis. So this axis that's here is this number that's here. Now it only works out if we start off with y is equal to, not 2y, not 3y, but just 1y. So y is equal to, and that will allow us to work out what our gradient is and what our c value is, which is our y-intercept. Okay, so let's put another equation up here. So what I'm going to do is I'm going to go for y is equal to 2x. I'll go for plus 3. So drawing it already. So what we can see is that I've got the same gradient, which is a gradient of 2, which would mean that every time I go along 1, I go up 2, along 1, up 2, along 1, up 2, as you can see. Same as the red line that's there. So these two lines are parallel because they've got the same gradient. The difference with these two lines is this value at the end, the c value, and that's where we cut through the y-axis that's here. So you can see that's 3. So what would you expect from y equals 2x plus 6? Let's see. Okay, y equals 2x plus 6. There we go. Okay, so what we're expecting is same gradient as the lines before, but what we can see is that we've got a c value of 6, a y-intercept of 6, or the coordinates of that intercept would be 0 along in the x direction and 6 up in the y direction. Okay, so it's the same for every line that we would draw that would be similar to that. And what we could go for is, what about one that's y equals 2x plus 12, would you expect? It's quite easy to understand once you see what the values will do. Y is equal to 2x plus 12. There we go. So it goes through 12. It's got the same gradient as these other lines that are here. So that's what we would expect. So remember, lines with the same gradient, so this value of 2 on the left-hand side is the same. Okay, the value in front of x is the value that's going to give us the gradient. And if they're the same, well, the gradients are parallel. Okay, so that gives us a bit of an idea of what to do when we're plotting some of these lines that are here. Okay then. So let's see if I can put that keyboard away just now and give us a bit more of the screen. So what if I had y equals, so I'm going to go for y equals, I'm going to go for negative 3x plus 1. So negative 3x plus 1. So what I would expect from that would be, if it's plus 1 and I've started with y equals, well, I'm expecting to go through that point there, that 0, 1 point, or 1 on the y axis. If I've said negative, so it's going to be a negative gradient, so I'm expecting to go down that way there. So I'd expect that if it's negative 3, every time I go along 1, I'm going to go down 3, along 1 and down 3. Let's see what that looks like. So negative 3x, and we've got a plus 1 going in there. Right, so there we go. So I'm going through this point here, which is 0, 1. As you can see it just appearing up on the screen. So 0, 1 is my y-intercept. The c value, if I was asking for that, is 1. Okay. The gradient, every time I go along 1, I go down 3. So it meets an intercept there. Every time I go along 1, I go down 3. So that'll be down there a bit further as well. Okay. And I could reverse the process by going 1, 3, 1, 3, you know, going back the way. But anyway, negative gradient running from left to right, downhill. And we can see that one appearing there. So what if I sketched in y is equal to minus 2x plus 1? What do you think would happen? So y is equal to minus 2x plus 1. Okay? So what I can see there is, because this number is the same, okay, and I'm starting with y equals, that number's the same there, so I know it's going to come through the same point on the y-axis. So it's coming through the point 0, 1. The only difference is that the gradients are different. So that's a negative 2 gradient. So what that would mean is, if I think about that as a fraction, negative 2 all over 1 would be every time I move along 1 in the horizontal direction, I go down 2. So for the red line that's here, along 1 down 2, yeah, along 1 down 2, along 1 down 2. So that works out for me there. Okay. So what if I went for, go down here, y is equal to, how about something like minus 5x plus 1. Minus 5x plus 1. Right, so what that would do is, minus 5x would give me quite a steep gradient, okay? Plus 1 would bring it up the way towards that point that's here on the 0, 1. So I'm going through the 0 point. So you can see common point at the end there, and I'm going through that point that's common between them all. Okay, so that's what your c value is in y equals mx plus c. Okay. Right, let's get rid of these ones here. So negative gradients there. What if I had y equals 2x plus 0? What would that do? What do you think? Let's have a look. Y equals 2x plus 0. Plus 0. Right, there we go. So what we know is that we're going through the point 0 on the y-axis. So that point there is 0, 0 we're going through. We've got a gradient of 2. So what that would mean is every time I go along 1, I go up 2. Along 1, up 2. So if I was looking at that line and trying to decide what the equation of that line was, well, I'd know that that's going to be 2x because of the gradient, and it's a plus 0, which is there. But in this kind of equation here, I don't really need to write in the plus 0, and I won't see that normally if I see the line drawn, because that draws the exact same line, y equals 2x. So if you see a line that says y equals 2x, then you know it goes through the point 0 on the y-axis, and that's the point 0, 0 actually on the coordinate diagram. Okay. What would happen if I put in the equation y equals 5x? Okay, so I'm thinking about the gradient. So I've got y is equal to 5x. I've not got a plus 0 in, but if I put a plus 0 in, so plus 0, all that would do is that would just draw it like that there, okay? So it's the same thing. So if I take that out, I'm starting to recognize that if I don't have anything after the 5x, I know it's going through the origin, as it's called, 0, 0, okay? That's where that's going through, there, okay? What if, right, I had the equation 2y equals 6x. What would that do you think? 2y equals 6x. Right, remember what we're saying is that what we don't want is any number in front of y. I only want one y. But if I was to write in 2y equals 6x, right, so what I've got here is a gradient of, as you can see, a gradient of 3. If I go along 1 and up 3, along 1 and up 3, and I'm passing through the origin, that's there. So this equation of a straight line isn't in its standard form, but really what that one is there is really y equals. And remember what we've been doing if we were to simplify that or solve that as an equation or write it as an equation, change the subject of the equation to y on its own, we would divide both sides by 2, and what we would end up with would be on this side would be 3x, y equals 3x. Okay? Right, so anyway, so if we get it in that form there, we need to convert it to y equals 3x to find our gradient and our y-intercept. On this one here, I'm just going to go back up and change this one here, and what I'm going to do is I'm going to put a +8 on the end there. So if I put a +8 on the end, where would you expect it to come through on the y-axis? So if I put a +8 in, but I'm starting with 2y, where would it come through the y-axis? Let's have a look. So there's the 8 in. Okay, so what that would do is if I've got 2y at the start, what I'm going to have to do is divide both the 6 and also the 8 by 2 to find the equation of my line. So that line there is really this bottom one, and it's a +4. Okay, that's what that would look like there. Right, so let's have a look at something else, okay? What would happen if I had, let's see, y equals, I'm going to go for 0x, and I'm going to go for +2. What would happen there? So if you think about the gradient, a 0 gradient is horizontal, so that's going to be flat, okay? So if I said 0x +2, what that would do is it would be a flat line, okay, all the way through here, and what I'm doing is I'm going through the point 0, 2, and the c value there would be a 2, as we can see from the equation up above. Okay. What that line really is 0 times x is 0, so that line there really would look like that there, y equals 2. Don't need to put the x in and the 0 in because they will multiply to get 0, so that won't make any difference to me at all. If I go for another one, let's go for y equals 0x plus 5. So y equals 0x plus 5 point. And what we get is we get a line going through the y equals 5. So if we simplified that down again, if I take away the 0x, the 0 times x, which is 0, y equals 5, so what that actually means is that for every point on that coordinate diagram, that straight line goes through y equals 5. So there's no slope to it at all, apart from the horizontal one. And that's the way that works. Okay, so whatever that number is there, so if y equals 5, that's a horizontal line that goes along through the point that's there. So I don't know if this can draw this type of line. So if I've got a vertical line, remember that was an undefined gradient. Well, that's a wee bit of a weird one. That's an x is equal to line. So x is equal to, and say we say x is equal to 6. So it's going to be a vertical line where all the time x is always equal to 6. So you can see that one there. What if I said y equals, or x, sorry, we'll go for x equals -2. Okay, let's go for it. X equals -2. And we'll see where that goes through. So it goes through -2 down here. So it's -2, 0. So it doesn't touch the y-axis at all. Okay, so it's an x equals line when it goes straight up and down the way. So they're a bit awkward, these three guys here. They're just a wee bit awkward. Okay. Right, so what do you think we'd get if I wrote down y equals pi x, if I can get that, if I can write that up. Y equals pi x. So remember, the number in front of the x is going to be your gradient. Okay, so if I was using touchpad, I could use this and go for y is equal to, there's an equal sign, like down there. And I said it was pi x, didn't I? So let's go for pi and x. There it is. So what that would tell me is that my gradient of this red line that's here is actually going to be, every time I go along 1, I'll be going up to 3.14 or pi. Every time I go along 1, I'll be going up 3.14. Every time I go along 1, I'll be going up 3.14. Okay, all the way. Right. What if I change that and I put y is equal to pi x plus pi? What would happen there? Well, I would think that this part here is just going to raise up and it's going to go to about there to 3.14. Let's have a look, see what happens. Plus pi. So it's just raised up. So it's just above the 3 on the coordinates there. We can see our 0 pi as well. Okay, so all that number there is going to do is show you where it cuts through the y-axis. So let's just look for at a simpler one. So we're going to go for 2x plus 3. 2x plus 3. What we've got is cuts through 3. So if I look at this line and I'm trying to work out the equation of it, I would know that my c value is equal to 3. And if I look at my gradient's 1 along and 2 up. 1 along and 2 up. So my gradient's going to be 2. So y is equal to 2x plus 3. Okay. If I looked at just another one, we'll go for a negative 4x, and we'll go for plus 2. Okay. So there we go. We're cutting through there at 0, 2, because if we'll try to find that, the equation of that line, c value is equal to 2. If I hide the keyboard, I can see that my gradient, every time I go along 1, I'm going down 4 places, along 1, down 4. So that's 1 on the bottom of a fraction and -4 on the top. So -4 divided by 1 will give me -4. So that gives me -4x. Okay, so we've had a look around at this Desmos system, but can you try things out? Just make sure you get a good understanding of what that c value does. Maybe put some other values in at the front there, like, you know, as we were saying, if we start with 4x, and we say that equals 20, no, we're not going for x, we're going for 4y is equal to 20x, okay, and say we go for plus 10, something like that, or, you know, that would give us 2.5, but let's go for plus 40. So there's that equation there. So again, if I was trying to work out the equation of that line that's there, what I could see is that for every time I move along 1 place, I go up 1, 2, 3, 4, 5, along 1 and up 1, 2, 3, 4, 5. So my gradient's 5. Okay, so 20 divided by 4 is 5. And my c value there is 10. So that's 40 divided by 4 will give me 10. So that's the way I can work it out if I don't get it in its normal form. Some other forms that we might get it in would be like 4y, and all I'm doing here is just moving the x values over to that side there of the equals 40. So if I make it a different number, let's make it, I'll go for 32. Okay, and what you can see there is that it will still draw the line in the package, But unfortunately, you know, it's harder to see the gradient. We need to get that over to the right-hand side and work out our gradient properly to try to work these things out from there. So things to play with are these parts here. You can also go into some of the examples that we've got here. If you look at the slope intercept form, this is a good form for us to use as well. And what we can do from this one is we can change the gradient by sliding along. So what would happen if I slide it to the right? So remember that m is in my equation, so my gradient gets steeper. If I slide it back the way, the gradient gets less steep to a point where I get to 0. If I can get to 0, there we go, it's flat, and then a negative gradient's going in the other direction. You can see that one. Okay, so if I then go to they've called it a b value, but we generally call it y equals mx plus c. Sometimes you'll see it as b, but try not to let that confuse you. What that should do is lift the line up. Okay, so if I go up to 4, my point that is clicking through here is going to be 0, 4. So it'd be good to have a play around with that, get a really good understanding of how the equation of a straight line works, especially around the gradient, especially around the value that's here, it's saying b, which is your c value, where it cuts through the y-axis. So I'll stop the video there, and I'll let you play with the Desmos, and make sure you get a good understanding of that. Unfortunately, we'll need to be able to sketch these lines and understand lines from the graphs and get the equations from the graphs. We'll be doing that in our next video. Okay, so cheers for now and good luck.